let's integrate z times the natural log of z squared dz. I'm going to start this by doing a substitution. So I'm going to let x equal the natural log of z, and I think that's a pretty natural thing to at least try on a problem that looks like this with that inside function natural log of z. I take a derivative and dx would equal 1 over z dz. And then dz equals z dx. Making that substitution, well, the dz would have a z dx in it, so I'd end up with a z squared times x squared, making that substitution, dx. And I guess I'm a little worried right now because my integrand still involves the variable z. So let's see if we can use our original substitution to help out with that. If x equals the natural log of z, then z equals e to the x, which means z squared is e to the 2x. So now I can rewrite this as x squared e to the 2x. This, now substituted, looks like an integration by parts problem. So I've picked a u and a dv, integrate, and differentiate. Let's apply the integration by parts formula and see what happens. U times v, I have 1/2 x squared e to the 2x minus the integral of v du. We'll go and write that 1/2 out front. Oh, I don't need to do that because I have a 1/2 times a 2 here, so I just end up with an x times e to the 2x dx. Well, looking at this one, I see another place where I can apply the integration by parts formula. So I'm going to pick a u and a dv. All right, so let's use that integration by parts formula just one more time. All right, need to distribute. And finally, just one more integral to worry about. I just need to make some more board space to make that happen. And there we have it. We have an antiderivative formula, but we're not quite done yet because, well, remember our original variable all the way back up here was the variable z. So I need to remember that any appearance of x, well, that's a natural log of z. And any appearance of z, any appearance of an e to the x is z. And because of that, any appearance of an e to the 2x is simply a z squared. And we actually have those written down all the way back at the very beginning. I just want a little reminder down here. So let's see, I have 1/2 the natural log of z squared, e to the 2x, that's times z squared, minus 1/2 the natural log of z times z squared. I'll put that in parentheses so we make sure that z squared's on the outside, plus 1/4 z squared plus c. And now we're really all the way to the end and found our antiderivative.